This week we will talk about arrays and mainly single dimension arrays. Instead of using separate variables, we use arrays. The main thing with an array is each cell has a specific location and the location does not change, and the system guarantees adjacent location. This is something you have to remember. You probably did some Java classes regarding arrays, but you have to understand how it works in this course. The cell has an index with which we access the data, and the index is also called an offset. All right. So the main thing that you take away from this lecture is the arrays are guaranteed to have adjacent locations. Okay, that is something. Okay, you have to remember. Let's say take a simple example here. I've declared int houses with 10 cells, each of type integer, and the size of we used operator, right? Size of, and you pass in the array name. It returns how much? 4 times 10. 4 is for the int. So many bytes, 40 bytes. House offset 0, which is the beginning of the array or the first item, first cell, first index. The index, like you in C language, just like in Java, the index always starts from 0. And how the name of the array is the name of the array, and it's also known as pointer constant. That means it always points to the first cell and it never changes. That's why it's called pointer constant, and that's very, very important concept, right? Okay, so house number 1 is the first element, house 2 is the second element. So the indices or the offsets, they go on increasing until the 10th item, whose index is 9. Each of these cells are physically located next to each other. Okay, that's something very important. The system guarantees for you. Alright, how do we store values? It's very simple. House with offset 0, we give some number. House 1, another number. House 2, another number. It goes on. So the name of the array and the offset. There are different ways of describing the offset. There's a syntax for that. The different ways. We'll go over that soon, or probably in the next lecture when we talk about pointers. All right. The indices or these offsets will never be negative. Okay, doesn't make any sense. So that is illegal. In our case, even though there are 10 cells, if you access the 11th item whose offset is 10, it's out of bounds, right? For instance, we only declared 1 second. We only declared 10 cells, and why are we accessing the 11th element? So you get out of bounds. Unfortunately, in C language, you don't have such concepts called out of bounds. It is your responsibility. The system will not check if you are accessing beyond the range. In this case 0 to 9. If you access the 10th element, the system will not complain to you. Alright? Will not complain. That's very important in C language. In Java, of course, you have exceptions. If you are taking a Java class, when you do out of bound, when you access an array which is not in the range, it will give you out of bound exception, right? But in C language, it will not complain. It is your responsibility. It is your responsibility to make sure that you are within the range. Alright? You are in the range. Okay? Right. The sad part is sometimes C will run okay because that memory location is accessible, and the system fetches you the data. When the location is not accessible, it will crash. Yes. Depending upon the systems, for instance, when we have integer, say data 20, and you say data, let's say, sorry, char data, say 10, I have x equal to 20, and I say data x equal to say 10, the system will not check if you are within the bounds or out of bounds. Here we are out of bounds, right? So sometimes when you have memory location that is in your sometimes in your program, when you have data, it will fetch the data even though the data is out of the range. It may not be very clear, but we'll write a program so you know. Alright? Alright. Let's go back to the PowerPoint. Reading data from the array is simple. House on the left hand side, it comes on the right hand side, sorry. It's very similar. Okay, there is no rocket science in this. We talked about size of house is 40 if it is integer. You have 10 elements, 4 times 10 is 40. A house of offset 0, the first element, if you do size of, it returns 4. Well, we know that, right? We know that a char, for instance, data 20, when you do size of data, it will return 20, because 1 byte times 20. And if you say size of data to 0, it will return 1. Yeah. Similarly, if you have integer, oops, int name, say 16, size of name will return how much? 48. 16 times 4, oh, 64. And the size of name 0 will return 4. So the size of, you know how to use the size of an arrays, right? Okay. What else we got? So different interpretation. The name of the array is also known as the pointer constant. We saw that. The name always points to the first cell of the array. Mere just the name, right? If you have an array, let's say data 4, this data is the name of the array that always points to the first element. Always. Let's say if it is char, so the memory, the system will allocate 4 bytes for you, point the data to the first element, and it will never change during your course lifetime of your program. Lifetime or during execution. You cannot change at all. Okay? It's concrete. That's very important. All right? The name is also the address of the first cell. Yeah, that's another. That is, in a way, the data is nothing but the address of the first cell. All right? Just the data means is the address of the first cell. If the address is, for instance, say, just for the sake of argument, let's say 446 is the first address of the first cell, data, and 446, you can just say data is pointing to the address 446, and is in a way this is a logical name for that. All right? Okay, enough of that. Let's go ahead and solve some problems. This is what I have written in our system. So we got the main. I also have that. One second, something. Okay. And I have declared an array, one array with 3 elements. All right, just like that. All right. and that means I have 3 locations. The sorry, one second. The one array is pointing to the first element, and I have not initialized this array. All right, it's always better that you initialize the array. You initialize the array always. The best way to initialize is always write the program in the program. You can write it in the program. Oops. One array 10. You can do that. So this is one way of doing it. Oh. Right. The other way is to initialize the array using a syntax which is a simpler version, 10, 20, 30 within the braces. All right, here we go. You can say 10, 20 and 30. There is no comma here. You see that? There is no comma there. Of course, semicolon. So it automatically will initialize to that. All right. Okay. Go to the program. So make a note of this. All right. And the address of this guy, I'm going to remove that and just put it in one way. Even though I have initialized the array using during the declaration, I also initialized like this individually, and to print the address of the array, you always use %p. Oops, what's going on? What's going on? Okay. All right. %p is gives the address. So I'm going to compile that for now. Okay, there's no errors. If you see the address of the array, it ends in 8040 in this case. Where is it? Here, the address of the first element is this address, is this long number. All right. Now, how do I print the address of this next element? You don't have to know now, but when we get into pointers, we'll talk about these address schemes, but just pretend that you know this for now, okay? The ampersand gives the address of the variable, in this case the second element. I'm going to print that. I'm going to print the third element, second, first, third. Oops. Two. What we got here, you see that we got the consecutive elements. Whatever the big address, the last, see the last 4 digits, QC D0, D1, the next address, and D2. They are consecutive. The addresses are sequential, very consecutive in increasing manner, right? That's why I said the system guarantees. Now every time you run, you will see that 30, 31, 32. You run it again. You see that? B0, B1, B2. Every time you run, it runs on a different location in the system, but those 3 elements are very consecutive. The system guarantees that for you. All right? Okay. So we know how to access the I'm going to just attach this program in the PowerPoint somewhere. Okay. Give me a second. Okay, so you can use it in your for your practice. Let me go back here. And I'm going to copy that 1.c to 2.c. 2. See how I copied? I just made a copy of the program. Oops. I'm going to remove them. So in order to print the values, second item, %d, right? One array is, second item is offset 1. And it will print 20, of course, right? And what if I want to, let's say I made it 65. 66, 64. I remove that. And I'm going to print as a character. What happens? You must be knowing that, right? You know what I'm doing this here. So it will print what? Letter A, because I'm printing as a char. The ASCII value 65, the character is letter A. Okay, so you know how to access it, how to store, how to declare. The one thing we didn't talk about, out of bounds. Let me again store this in the PowerPoint. Okay, let's go back here. This time I'm going to copy again 2.c to 3.c. Oops, I made a mistake. 3.v is not. Copy 2.c to 3.c. Oh my god. Alright, here I am going to say one array, say fifth element equal 20. So like I said, this is a wrong program, right? This is very wrong. There is no such element as fifth element. This is where crashes occur. Oh. Okay, you see that? We have only 3 items, but I'm accessing the fifth item. I'm storing in fifth item. This is quite dangerous on many fronts, on many cases. Where is that? Yeah. So there's no such thing as fifth element. Zero, 1, 2, 3, 4, 5. This is quite dangerous. You are putting some value out of the box, out of the array. Let's see what happens. All right. Like I said, it will run sometimes. Sometimes it won't run. Yeah, fifth item is 20. Let me put 66. Why is that? That's because somehow your program, let me describe here. Somehow your entire program, right, when it's running in the system, it has additional space meant for your program. It's continued extending the array into that memory location, all right, and you are lucky. You just got lucky. But let me do this. A big number, all right, a big number. This will guarantee that hopefully, this will guarantee that this will not be in your address space. Okay, the chances that it will not, it crashed. You see that? It crashed. You crashed the system, your program, not the system. Why? It's quite dangerous. You don't know when you are going out of bounds and when you got lucky. All right? So when you are dealing with large amounts of data, you got to be very careful in accessing the locations. In a simple embedded systems, when you run embedded systems, Out of bounds will not be tolerated. Will not be tolerated by the system. Why? Because the memory is very small. And anything that you're accessing out of bounds will result in crash. But in big systems like ours, you have to be careful. Sometimes it will work, sometimes it won't. And most of the time, you have to take care of this. Alright? You always have to say, if my offset, let's say my offset this is my offset, right? Okay. You always have to say if offset is greater than -1 and offset is less than 3, you have to, like I said, it is your responsibility that you are within the range, because you have declared only 3 items. You have to say if the offset is less than 3 and it is a positive from 0, then you do it. Otherwise, else, exit. You crash the system with a 9 or something. But of course it won't. Let's not worry about it. So you always say if your offset is within this range, then you assign. Alright? Or you could just say plainly else offset equal to 0, maybe. The other way option is okay, if the offset is greater than 1, less than 3, you assign something, you print, and you exit out of the system. Now you compile, it won't execute because your offset is way too high, right? So like I said, it is your responsibility to make sure this array is within your range. The other thing, best programming practice is you define max array to be 3 and use that maximum array here. This is a constant you define. It's a numeric constant. You can always, in C language, this is how you do it. Oops. You always define like that. And now what is the advantage in using maximum array? Instead of using hard-coded values like 3, why is that? That is because if your boss later comes and says, hey, can you change the array size to some 1000, you don't have to go and read the entire program and change everywhere else. You just change it in one spot. That's it. You don't have to change anywhere else. Right? So that is the advantage of as defines. Alright. I also tell you, when does the system expand or replaces all this maximum arrays to 1000? When does it do? It does at the compilation time. So how do I know that? Okay. So all constants, here it is. I'll explain that to you with a as define. Say maximum. They all should be uppercase. All right. That is standard we use in C language. In Java, what do you use? In Java, you use final, right? Okay. Here, so this is a constant. And it will the compilation, during compilation, the system will replace wherever max array is defined, replace with 1000. That's what it means. And remember one more thing, while you are at it, there is no semicolon here. No semicolon, right? No semicolon. Go back to the program. Okay, we said how does it do it? So okay, let's go back and do it. How do I find out? Man, GCC. If you see this minus E option, I think that's what it says, end in pre-processing. It's also called pre-processing. That means during the very first pass, replace it. I mean, very first pass, when you replace all these things, stop the compilation. Pre-processing means when you are doing one pass, that's what it is, basically. So let's go ahead and see what's defined as minus E. Minus E, not here. I'm just using space bar to navigate the man pages. It says minus E. I think that's what it means. Let me check, confirm. Oh. Pre-process. Okay, here it is. Minus E, stop after the pre-processing stage. Do not run the compiler proper. The output is in the form of pre-processed source code, which is sent to the standard output. That means standard output is our screen. standard output is our screen. Display, right? It says when you do pre-processing, send the results to the standard output and don't do the compilation fully. That's what it means. Okay, how do I do it? -E option. Let's go back here. GCC -E 3.c. When I did it, you see that I defined. Okay, let me go back to the program. My maximum array is 1000, and the pre-processing will go ahead and replace 1000 maximum array with 1000, maximum array with 1000, right? So let me compile again. GCC -E, and it's basically send the output to the screen, replacing all the values. Okay. So -E option, remember, -E. Okay. So in this lecture, we found two things. I'm sorry, many things. One is the array, how to declare, how to initialize, how to read data, how to write data. All right, how to keep accessing within the range. We saw the dangers of out of bounds. Dangers of out of bounds, right? And how to use hash define, mainly in case of arrays, definitions. In all professional programs, when you go to corporate world, you always use hash defines, because your code should be very modular, very readable. If you are going to write code everywhere with numbers like this, nobody knows what this number is, right? You may understand it. What if your coworker, somebody else is managing the code now, and he goes and changes this 1000 into 2000 here, and the whole code will just crash. That is why you need to use hash defines. So there's only one place you change. We saw that, all right, and we wrote a program to test all these cases. Okay, 1 second. And then we saw the how to do pre-processing oops, I made a mistake. Pre-processing command is minus E. All right. We saw pre-processing command. How do we do that? Is gcc minus E file name dot c, and what does it do? What does it do? A very important question, right? Here is that. So you have your file, let's say file name .c. You took this program, passed to GCC with a minus E command. What it does is, does a pre-processing, make sure that the syntax okay, make sure that it expands all the macros, definitions, okay, and it doesn't generate machine code. It does not generate machine code. It plainly expands this program, pre-process it, and sends the output to the standard input, which is output, which is our monitor. If you want to send to a file, if you want to send this to a file, not the monitor, right? For instance, here, if you want to send it to a file, let's say another file, you want to send it to a friend, gcc minus E greater than sign, it will send it to preprocess.c. All right. If you don't do that, it will send it to a screen. If I don't have that greater than sign and any file name, it doesn't have to be pre-process, okay? Can be any name. If you do that, then it goes to this screen. But if you give a file name with a greater than symbol, I'm sorry. Anyway, so that's the pre-processing. So we saw pre-processing too, how to do pre-processing. That's one command, gcc minus E file name dot c greater than SAM, let's say. Okay, so this is the first lecture. In the next lecture, we will solve lot of problems, sample problems.